Can we find a use for the L3 Lagrange point? How long do the Voyagers have left? Which goals do we have for telescopes that are being built? And in Q&A Plus, what is the most important technology that we can focus on? All this and more in this question show. It's time for the question show. Your questions, my answers, as always, wherever you are across my channel. If a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get to the questions. Santiago T75. Fraser, do you think there could ever be a practical use for the Lagrange point 3? Finally, a Lagrange point question. Like, have you forsaken the Lagrange points? So Lagrange point 3, the Earth-Sun L3 Lagrange point. And so if you sort of think in your mind the various Lagrange points, L1 is in between the Earth and the Sun. L2 is on the other side of the Earth, opposite from the Sun. And L3 is on the opposite side of the Sun. If you imagine, it's sort of like counter Earth. So, wherever the Earth is, in the exact opposite side of the Sun, at roughly the same distance from the Sun, although it's a little bit different than that, is where the L3 point is. And so it is another roughly gravitationally stable place where you could position a spacecraft. It's gravitationally unstable. And so you still require fuel, but you require less fuel than you would need to be in any other location to remain in that spot. And so what would be the value of having a spacecraft on the other side of the Sun from the Earth? We couldn't communicate with it. So that's a big downside. Well, it could observe the far side of the Sun. We can observe the near side of the Sun. An object on the L3 point would be able to observe the far side of the Sun. And then we could combine our data to see a full map of the Sun at any time. The other idea, and this is one that I really like, is that the other Lagrange points, L4 and L5, are ahead and behind the Earth in its orbit around the Sun. And so if you have the L3 point on the other side of the Sun, then L3, L4, and L5 form a giant triangle, roughly an equilateral triangle. And then you could make an interferometer. And so people have done calculations that, the L4 points, that you sort of imagine, all of the Lagrange points, L4, L5, and L3, are sort of orbiting around the Sun with the Earth as the Earth is going around, and that the Earth is on an elliptical orbit around the Sun. But in fact, if you put objects in orbit at the L4 and the L5 and you hold things stable at the L3, then you can keep your spacecraft within about 10,000 kilometers of a perfect equilateral triangle at all times. And so that would allow you to have this interferometer, probably not a visible light interferometer, although that would be amazing, wouldn't it? But maybe a radio interferometer. So you build a version of the Event Horizon Telescope that has a baseline of 250 million kilometers. When you consider the size of the current Event Horizon Telescope, where it's the size of planet Earth. Imagine if you had one that was that much bigger. Big radio telescope at each one of those points, forming the equilateral triangle, creating the most gigantic version of the Event Horizon Telescope. You could then look at event horizons of many, many, many more black holes at incredible resolution. So that's a perfectly good use. There's been other ideas that you could use the L3 point for, but it doesn't come up very often because it's on the other side of the Sun from us. RMS 492, how long are the Voyagers expected to continue communicating with Earth? About 10 years. So the problem with the Voyagers is that they have this decaying piece of plutonium that provides their electricity, and plutonium has a half-life, and these things are nearing 50 years old, and the amount of electricity that they're able to generate, really the amount of heat that the plutonium is able to generate, has gone down over time, and eventually they're going to get so low that they're no longer able to power any of the science instruments, no longer able to power the transmitter, and then NASA will officially shut those missions down. And they've already been shutting down their instruments one after the other. So we are probably within about 10 years of when they're going to have to shut down the Voyagers forever. Billions and billions of stars. Is it true that the golden records will last for billions of years? If so, then the records might be the only things left of humanity. Yeah, it's about 1 billion years. So the golden record, which is this record that was put onto the Voyager spacecraft and it was sort of put in a protective case. And when they were built, the engineers did the calculations that, these things are going to be out there floating through space, constantly hit by cosmic rays, high energy particles, as well as dust, and that it's going to slowly degrade the outer surface of this, wear down the protective case, get through the golden records, and it's expected that it should last about 1 billion years. And so if humanity does nothing else to preserve any kind of record that we were here, then the golden records, but really just like the Voyagers themselves, all of the spacecraft that we've sent will be the record of that we were here. But if we put our minds to it, we can come up with ways that we can leave a record that is more obvious, easier to find, and will be more durable. And when you sort of think about 2001, this idea that they put the monolith, that the aliens put the monoliths on Earth, they put it on the moon, they put them in other places in the solar system. They said, okay, when you're ready, you will discover this thing that is a record that's going to give you information about how to live in the cosmos, where all the other aliens are, how you can integrate with this larger galactic federation. And so we could do the same thing, which is that, and people are proposing this right now, that we should build some kind of vault, some kind of archive that we put on the moon that is very obvious, that if you can make it to the moon, then this thing is there and it will last for billions of years and be obvious on the surface of the moon. And that when humanity doesn't live up to its potential, ends, and then the octopuses rise up and they build their spacefaring civilization and they get to the moon, they'll find some record that we were here. And there's this really great idea, and David Kipping sort of talks about this in some of his videos, that we will be able to communicate into the future with a future civilization that arose on Earth. And that's the most likely intelligence that we will ever be able to communicate with, is one that also formed on planet Earth. And so we should come up with a way to give them Wikipedia or some record of our knowledge so that when they make it to the moon, they can find that and they can use that to enrich themselves. Because chances are, they will attempt to go to the moon at sort of the similar technology curve that we're at, or that we were at when we went to the moon. And so we can share this information, help to advance their civilization. We'll be long gone. We'll be this precursor civilization that's long gone, is giving them information from the past, teaching them about their heritage and their history. It would be really cool, apart from the fact that we all died, but still. So yeah, we should definitely leave a long-term record that is easy to find, unlike the Voyagers, which are hard to find. Yenvi Freyr. Could we theoretically detect intergalactic visitors instead of just interstellar ones? It's interesting. So, when we think about us detecting interstellar objects, we are detecting them, like, we know that they're interstellar objects because of the orbit that they are moving on as they pass through the solar system. And so, normally objects are following an elliptical orbit, but an interstellar object is following a hyperbolic orbit, which means that it is not going to remain inside the solar system. And that is the giveaway that that is going to be passing through the solar system. But would you be able to detect the difference between an interstellar object and an intergalactic object? Probably. And the way you would do that is purely through the velocity. And so, while an interstellar object needs to be moving, when you sort of think about the escape velocity from the sun, if you were like right on the surface of the sun and you're trying to escape the solar system, your escape velocity is a little over 42 kilometers per second. So if you're going faster than that, then you are going to be able to escape the solar system. If you're going slower than that, you're going to be captured by the solar system and orbit it in some way. Now, obviously, there's how far away you are from the sun depends on the speed you want to be going. And so objects that are moving around inside the Milky Way are going to be coming in at these velocities that allow them to escape again, and they're going to be in that range. And so all of the objects that we've seen so far, when you think about Oumuamua, you think about Borisov, you think about 3i Atlas, they've been going fast, but sort of in a range of each other. maybe within 10 kilometers per second of being able to escape the solar system. But for an object to move from galaxy to galaxy, to be an intergalactic object, it had to escape its original galaxy. And so that requires a lot of velocity. The escape velocity of the Milky Way is like 250 kilometers per second, which is dramatically faster than the, say, 50-ish kilometers per second you might expect an object moving through the solar system, or even less, 30, 20, right? And so for an object to actually be an intergalactic object, it would have to have been kicked out from its galaxy faster than 250 kilometers per second. So maybe it's going 300 kilometers per second. It would be passing through the solar system at 300 kilometers per second. And so astronomers would identify this object, see how quickly it's moving, and they'd say that not only does that object have enough velocity to escape the solar system, it has enough velocity to escape the galaxy. And so that is a true intergalactic object. And we know that stars are on intergalactic velocities. There are stars on escape velocities. We have seen exoplanets probably on escape velocities, like stars that are on escape velocities that are probably bringing their planets with them. And so they would also be carrying their Oort clouds with them, and the Oort clouds would be dispersing. And so, almost certainly there have been intergalactic objects passing through the solar system throughout its entire history. That would be incredible. And the way you would tell is the speed. You go like, that thing's moving too fast. Has to have, it's on an escape trajectory. It might have been kicked out by the solar system. It might have been kicked out through some event in the Milky Way, but it is also possible that it was kicked out of a different galaxy and has made the journey to us. Be incredible. It's time to shout out all the new $5 patrons and above. Dace Janice Malowski, Johnny Brown, Randall, Marino Hernandez, Dale Chess, Oh Good What Luck, Commander Bayluck, Tim Hamill, MB Code and Sound, M. Mueller. Join the club at patreon.com/universe today. Jow Dias Doom. What are the specific goals for all the biggest telescopes built or being built? For the biggest telescopes that are being built, and there's this whole new class of giant telescopes that are under development right now. There's the Giant Magellan Telescope, which is a 30-meter class telescope. There's the Extremely Large Telescope, which is a 39-meter telescope. And the purpose of all of these telescopes is to create a really big telescope that astronomers can use for whatever they want. The biggest telescopes on Earth right now are in this 8-meter class range. There's a bigger telescope on the Canary Islands. It's 10 meters across. There's the Large Binocular Telescope, which is 2 8-meter telescopes side by side. And there's the Very Large Telescope, which consists of 4 8-meter telescopes that can operate as a single telescope that is a larger baseline. These are used for all kinds of stuff. They're used to find exoplanets. They're used to observe quasars. They're used to look at Betelgeuse. They're used to look at objects in the solar system. They're general purpose tools. And so the next generation of telescopes are going to be able to be these general purpose tools, but they're going to have like better scientific instruments on board, much larger apertures that are going to allow them to resolve features that are smaller on other objects. But there are some specific science goals that have been proposed. Like when you're sort of setting the limit, the size of this telescope, you kind of want it to be able to accomplish some specific stuff. And so one example is the Extremely Large Telescope, the 39-meter telescope that's in construction. Should be done in 27, so we're like 2 years away from this telescope. It should be able to resolve Earth-sized worlds orbiting around sun-like stars. Should be able to pick out a Earth orbiting around a star like the sun. They need to know which star to look at. But once it does become operational, then theoretically it should be able to find them. So that's the kind of thing you're like, well, you need at least a 39-meter telescope. You need a coronagraph that has this level of capability. And then one of the things that you should be able to do is make this kind of observation. So, but really this next group of big telescopes are just giant light buckets that astronomers can use for whatever tasks they need. And then they're going to have a suite of instruments on board that make them good at very specific kinds of things. Like, even on the Very Large Telescope right now, it has the sphere instrument, has the gravity plus instrument, things that are used for helping find exoplanets, or things that are used for doing photometry, or things that are used for looking at the polarization of light. And these have other purposes as well. So stay tuned. There's this giant class of telescopes, 30-meter plus telescopes. There's 2 for sure under construction, and then there's the third one, the 30-meter telescope, that was originally going to be built on Mauna Kea in Hawaii, and now it's probably going to get built in the Canary Islands. They haven't broke ground on it yet. They haven't even sort of decided that's where it's going to be, but it really looks like that's where it's going to be. And so we could see that telescope come online after the other big ones. But, within 10 years from now, we should have 3 30-meter class telescopes in full operation here on planet Earth. Briscoe Rob, I'm sure there's an unlimited amount of platinum in asteroids. Is this not a priority to gather? The problem with gathering any rare element from asteroids is the expense in getting to the asteroid and picking it up and bringing it home. And so I've said many times that, if there were bars of platinum sitting on the surface of an asteroid, and all we had to do was fly to that asteroid, reach out with our little grabber arm, pick up the platinum, tuck it away, bring it home, it would still be too expensive compared to digging platinum out of the ground. And so until going and getting metal from an asteroid is less expensive than digging it out of the ground, we will be digging it out of the ground. So that's the problem, is that it's just still way too expensive by orders of magnitude. Let's say that, and it's not bars of platinum sitting there on the surface of the asteroid. It is platinum that is mixed into the asteroid at higher concentrations than you would find down here on Earth, but you would still need to extract the minerals, have some kind of facility for being able to concentrate it and bring it home. And you're looking at tens of billions of dollars to do that today compared to digging a hole in the ground. Like, what kind of a mine could you get for $100 billion? Like a pretty good mine. Crystal, what is the most important technologies to focus on, and why is it the linear mass driver? I mean, there are a lot of important technologies to focus on. The linear mass driver, there's a couple of reasons why it would be amazing, which is that you would be able to launch payloads off the surface of the Earth without having to use propellant. You just use electricity, and we have lots of electricity, and you would just accelerate payloads off the surface of the Earth and they go into space. That would be mind-blowing. And even if we couldn't do it off the surface of the Earth, then we could still do it off the surface of the moon. In fact, it's probably the best and only way that we're going to be able to accelerate payloads off of the surface of the moon. There was an interview that I did about a year ago with a Finnish researcher talking about the best way to do that you sort of time things perfectly. You can be launching payloads off of the surface of the moon. You have a long time to be able to catch them in orbit before you can then take them away from lunar orbit. And once we're doing that, once we have a accelerator on the moon that is throwing material off of the moon into orbit, we're catching that and then we're putting it to work. It's propellant or it's regolith that we're turning into the O'Neill cylinders at the L4 colony. Then we're living that future spacefaring civilization. The other thing is you put them on asteroids. You put your mass driver on the asteroid, you are mining the asteroid, you are flinging the material off of the asteroid towards a collection point, and you are also changing the orbit of the asteroid to make it safer. And so you could take a near-Earth object, something that is potentially dangerous to the Earth, and you purposefully put a mass driver on that object. Think about Apophis. You put a mass driver on Apophis, you are mining Apophis for our future space exploration needs, and you are making the orbit of Apophis safer. And eventually we can have mass drivers on every single dangerous asteroid, every near-Earth object in our vicinity. And we are just taming them all, pulling all their teeth so that we can use their material to fund our future spacefaring civilization. So yeah, is it the most important technology to focus on? Probably not, but it is definitely very cool and very important. All right, those are all the questions that we had this episode. Thank you, everyone who asked your questions in the YouTube comments, everybody who joined me for the live show. We recorded the show every Monday, different time, but the next episode when you're watching this is going to be Monday, January 12th at 5 p.m. Pacific time. And that'll just be right here on YouTube, a live show. I will answer your questions. Bring them. Now, previously this week, I talked about the anime that sort of formed my thinking. Now I want to talk about role-playing games. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Barely Grooving, Brian Bodie, Caradwan, Chuck Hawkins, Commander Balak, Cy Nielsen, Dark Finger, David Gilton, David Matz, Evan Pro, Greg Feely, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Marcel Sutz, Michael Purcell, Nordspace, OneStepForAnimals.org, Paul Bach, Rink Heidi, Richard Williams, Sean Sargent, Stephen Fowler Munley, Team 49, Telescopes Canada, Wolfgang Klotz, and Zeldaborg Galactic Defender, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So last week we had the final episode of Stranger Things, and although I wasn't super excited to watch it, we did sort of feel like we've gone through the journey to this point. We finished it off. It was fine. You know, I feel like maybe they didn't need to drag the show along as far as they did, but you know, they did. But if you go back to the first season and you had the kids playing Dungeons and Dragons in that, they clearly like just put a target right on my brain and just said, hey, this was you in the 1980s, Fraser. And it totally was, which is that I was that exact age at that time, gathered together with my friends, and we were playing Dungeons and Dragons. The same books. The same, like everything. I even knew which adventure they were running in Stranger Things. It sounded like it was Ravenloft to me, but I'm not sure. But so I was first exposed to role-playing games, I think like the late 70s. So like the Dungeons and Dragons, like the Chainmail edition, I think came out in 1971. That was the version that I played. I couldn't have been more than 8 or 9, the very late 70s. Friend had these little booklets that had the rules for Dungeons and Dragons, and we played an adventure, and it blew my mind because it was kind of like a board game or like a video game, but you could do kind of anything and go anywhere, and you could fight monsters, and the world would change as you made decisions. And it was, of course, this sort of shared theater that you're having with these other people. And yet it was just transformative to the way that I sort of perceived games and play. And then sort of went on to meet other people, and other people were running games and campaigns. Some were amazing, some were garbage. And it formed like a really heavy part of my childhood. So much so that I attended role-playing game conventions when I was in my teens. I went to science fiction conventions. We would play role-playing games at high school. And then even when I was in university, I organized role-playing game conventions at the University of British Columbia. So I was like absolutely super. Oh, and I also started writing for role-playing game companies. So yeah, I was in pretty deep. And yet it has been this common thread that has carried out through my entire life. When my kids were old enough, we would run a simple version of Dungeons and Dragons. And now I am the dungeon master for my kids who are in their early 20s and a bunch of their friends. And we're doing a really kind of compelling campaign that has some very dark and sort of mature themes. And yet this is a thing that I can do with, you know, this is a game, you know, I can tell a compelling, dark story and, you know, sort of keep everybody on the edge, and it's fun. And so I think if there's people out there who are like watching this and, you know, you watch Stranger Things and, you know, you're kind of interested and you've watched things like Critical Role, and there's like a lot of like a resurgence of role-playing games, and yet you've never had a chance to play, and you're playing video games. It's not the same thing. It's just not. Do what you can to get into a game, to get into a campaign, find a dungeon master, find some people. And like, you're going to have to come out of your shell to find a group who you can play with. And yet, if it works out well, you should have what I think is a transformative experience. It genuinely takes your mind to another place in a way that reading or watching a television show or watching a movie or playing video games just doesn't do. So here is like my top recommendation. Go play a role-playing game. All right, we'll see you next time.